All right, so before we get started with today's lecture, I want to impress upon you the necessity, the importance of doing the review on the properties of exponents. We're going to talk about logarithms today, but the key to understanding logarithms is really just understanding how exponents work. Okay, so if you recall in the review, I talked about power functions. Okay, we talked about how exponents work, and then at the end, we talked about power functions. Okay, we talked about a power function as a variable base raised to a constant power. Okay, so something like, whoops, something like x squared, right? Or y to the fifth, right? Those are power functions. Okay, um, so now we're going to talk about exponential functions. So what's the difference between a power function and an exponential function? It's a very important difference. The big difference is that an exponential function is a constant positive real base, okay? Constant positive real base raised to a variable power, okay? So for example, 2 to the x is an exponential function, all right? Now in that review, I also talked about inverses, and we talked about the inverse of a power function. So the inverse of a power function, like say x squared, would be x to the 1/2, right? Or you could write it as the square root of x, right? That would be the inverse of that power function. Y to the fifth, the inverse of that would be y to the 1/5, right? That would be the inverse of that power function. So the inverse of a power function is another power function. Now, what about exponential functions? Okay, so think about what this is. Again, an inverse is the undo of a function. So if we have an input of 5, let's say, so we're putting 5 in for x, right? And what do we get out? We get 32, right? Because 2 to the fifth is 32. We want the inverse to take the input of 32 and give us back 5, right? So what function will do that? Well, we need to define a new function called a logarithm. A logarithm is what gives you the exponent. It gives you the exponent that you would have had to raise the base to in order to get the value that you're taking the log of. Okay, so the definition of a logarithm is the log. So if we have something that looks like this, a log with a base of b, right, of y is the exponent. It's the exponent on the base b that gives you y. Okay? So the log is the exponent. The log is the exponent. The log is the exponent. Drill that into your mind. The log is the exponent. The log is an exponent. Okay? So it's the exponent you get, or it's the exponent that you would have used to raise the base to in order to get the result that you're taking the log of. Okay? So the log base 2 of 32. Okay, so here we the log base, 32 is the input, right? So the log base 2 of 32 is 5, right? Because that is the exponent that we would have had to raise the base to in order to get 32. Okay? So let's do some practicing. Let's do some practicing with just converting back and forth between these two forms. We have logarithmic form. We can take an expression in logarithmic form and we can write it in exponential form, in an equivalent exponential form. Or we can take exponential functions and we can write them in logarithmic form. Okay, so that's what this is saying here, is that these are equivalent. This stands for if and only if, and only if. Okay, so the log base b of y is equal to x if and only if b to the x equals y. Okay, so that means essentially we can take those numbers b, y, and x and rewrite them in either one of these forms. So let's practice doing that. All right, so example 1, we're asked to rewrite, I'll leave that definition logarithm up there, rewrite the following logarithmic equation in exponential form. Okay, so let's identify the parts, right? This is the base, right? This is the exponent. The log is the exponent. The result of a log is always an exponent. Okay, and then this is the result, right? This is the result. So the base, if we want to write this in exponential form, we could write the base to the exponent is equal to 81. Right? That's all there is to it. Just identify the parts. We had the base, we had the exponent, we have the result. Okay, the result is actually the argument of the logarithm. It's what you're taking the log of. All right, so if you would like to, you can pause the video here and try this one on your own. It's always good to try these things as soon as you learn them, and so that you can remember. So pause the video, and then you can come back and I'll show you the answer. All right, so we have the base, right? So it's going to be 4 to the exponent. The exponent is 1/2. 4 to the 1/2 is equal to the thing we're taking the log of. It's 2. Boom. That's it. That's all there is to it. All right, so let's take a look at another one. Now, here we're given an exponential form, and we're asked to put it in logarithmic form, okay? So we have the log. Now we need a base, right? So if you recall, I can't get this all on the screen, but it has a base. So the log of base b, now, so the base is 7, okay? And the result is 49, and that's equal to 2. The log is the exponent. So the result of the log is the exponent, okay? The result of the exponential equation is the argument, okay? And the base is the base, right? So what this is saying is that the exponent on 7 that gives you 49 is 2, all right? All right, so there's one more here in this set of examples that, again, you can pause the video and try this on your own. Try rewriting this in exponential, this exponential equation in logarithmic form. All right, so hopefully you've tried it, and so let's take a look. All right, so we need the log with a base of 5, okay, and of 0.4, okay, is equal to the exponent minus 2. Okay, the result of a log is always the exponent on the base that gives you the number you're taking the log of. Okay, so that is that expression, that exponential expression in logarithmic form. All right, well, the next thing we're going to talk about is the common logarithm and the natural logarithm. I'll meet you in the next video for that.